Hello everyone, myself Adarsh Sharma, roll number 21NS0245, Maths Department. My topic is Newton's ring. Newton's ring. Introduction. The format of Newton's ring is an important application of inference of light wave from the opposite faces of a thin film of varying thickness. Formation of Newton's ring. A thin air film of increasing thickness in all directions from one point can be easily obtained by placing a plano-convex lens of a large radius of curvature on a plain glass plate. You can see the figure. When the air film is illuminated normally by monochromatic light, the observation inference rings are circular concentric rings with center as the point of contact. The rings are circular since these are the loci of points of equal optical film thickness. The rings gradually becomes narrow as their radius increases. You can see the figure. There is an eye and the source. AB is a wave incident at point B on a plano-convex lens. DB and B1 D1 are wave originated by reflection from lower surface of plano-convex lens and upper surface of glass plate. These two inference of the given reference circulate rings by reflected light. CE and C1E1 are transmitted waves on the other side of film. These also product inference circular rings by transmitted light. Newton's ring by reflected light. There are two conditions. Condition of maxima. 2 mu naught equals to n plus 1 by 2 lambda. And second condition is condition of minima. 2 mu t equals to n lambda. Radius of Newton. There are two types of radius of Newton. One is dark ring and other is bright ring. In dark ring, Rn equals to SQRT and lambda R by mu. That's equation number 1. Radius of Newton, bright ring. Rn equals to SQRT n plus 1 by 2 lambda R by mu is equation number 2. Diameter of nth ring is given by Dn equals to 2Rn. Formation of equation. D1 equals to 2 SQRT lambda R by U and D2 equals to 2 SQRT 2 lambda R by mu. D3 equals to 2 SQRT 3 lambda R by U. The difference in the diameter of two nearest dark ring is given by D2 minus D1 equals to 2 SQRT lambda R by mu SQRT 2 minus 1, which equals to 0.414 into 2 SQRT lambda R by U. D3 minus D2 equals to 2 SQRT lambda R by mu SQRT 3 minus SQRT 2, which equals to 0.318 into 2 SQRT lambda R by mu. D4 minus D3 equals to 2 SQRT lambda R by mu SQRT 4 minus SQRT 3 equals to 0.268 into 2 SQRT lambda R by mu. Hence, the rings gradually becomes narrow as their radius increases. It can also be shown that the brighter ring also gradually become narrow as their radii increases. Newton rings by transmission of light. There is two conditions. One is condition of maxima, 2 mu t equals to n lambda. Condition of maxima, 2 mu t n plus 1 by 2 lambda. Difference between Newton rings by reflected light and transmitted light is, in the reflected system, there is a phase change of pi between the two reflected light ray, while in the transmission system there is a phase change of 2 pi between the two transmitted light rays. Therefore, the condition of maxima and minima are opposite in two systems. Hence, the center in the reflected system is dark while the transmitted system is bright. Determination of wavelength by method of Newton's ring. From equation 1, diameter of nth ring, dark ring, is dn equals to 2 SQRT n lambda r. dn2 equals to 4n lambda r. From equation number 1, diameter of n plus mth dark ring is 2n plus m equals to 4n plus m lambda r. dn plus m minus dn equals to 4m lambda r. Lambda equals to dm plus m minus dn square by 4mr, which is equation number 3. Hence, measuring nm, dn plus m and r lambda can be determined experimentally. Experiment setup. As you can see in the figure, the cross wire of microscope is fixed at the particular dark ring, say nth, and reading is noted on microscope. The microscope is moving to diameter opposite side and the cross wire is fixed on the same ring and reading is noted. The difference between the two rings will be the diameter of the particular ring nth. This procedure is repeated from another ring, say n plus m. Thus, diameter of n plus mth ring is obtained. The ring of curvature r of the lower surface of the lens is measured by a spirometer, and by putting the value in equation 3, wavelength of light is determined. Thank you.